Hi, I'm Tom Niedermeyer with the AMF Training School. Welcome to our Partnership Program Maintenance Matters video series. Today we'll be working with ball lifts. AMF strongly suggests that whenever you're working in the Pinspotter, the power plug should be removed. And that power plug then placed into a lockout box. And the lockout box should be padlocked to prevent anyone other than the mechanic who has locked it out from being able to re-energize the machine. In the case of working with the ball lift, it's recommended that the power plug from both machines using that lift be removed and locked out. In preparation for removing the ball lift, we need first to remove the lift guard and also the back end guard. We need to remove the spring for the ratchet wheel drive belt. We take off the spring for the hold down and the extension rod. And we have the spring for the belt tensioner. So after disconnecting the belt tensioner spring, we have to remove both drive belt springs. We're going to take the clamp studs out that hold the belt tightener in, just to get the belt tightener out of the way. And we need to remove the clamp studs from the lower ball lift link assembly. If the clamp studs are tight, we may need to tap them on the end just a little to free them. We do that before the nuts clear off so we don't damage the threads. We need to remove the 4 belts from the bottom ball lift shaft. Next, we remove the upper link assembly clamp studs. With the upper clamp studs removed, the ball lift is ready to come out of the machine. With all of the springs, belts, and link assemblies disconnected, we're going to bring the lift forward and then up out of the machine. Once the ball lift is out, it's much easier to inspect the track rail assembly. We start by looking at the track rail covers, checking the condition of the covers, whether they're oily or excessively worn, possibly turning them to bring a new surface to bear against the ball. We'd look at the lift arm itself, checking the liners that are on top of the lift arm and the height of the lift arm above the exit. The height of the lift arm is controlled by the 11049 rod, where it comes back to the ratchet wheel here. This rod has right-hand thread on both ends, so it's necessary to disconnect one end of the rod to change its length. Shortening the rod will raise the lift arm, lengthening the rod will lower it. We're looking for about 3/16 of an inch of the lift arm showing above the bottom of the weldment. We'll also inspect the weldment for any cracks, any hardware that's loose, or any obvious condition that would mark a bowling ball as it rolls into the exit. After completing our rebuilding process, it's time to reinstall the ball lift in our Pinspotters. Once we have the ball lift back in the Pinspotter, we put the upper link assembly in position and we can put our clamp studs back in. We don't tighten them up, just install the nuts to hold them in position. Before we put the lower link assembly in position, we do have to install the ball lift drive belts. One from each machine, right-hand machine and left-hand machine, and they must go around the lower link assembly before it's positioned. So we've got the belts in position, and we can put the lower clamp studs in place. Once the clamp studs are installed, we snug them just slightly to hold the lift in position, When we check our alignment, we want the lift belt to be centered on the return track assembly. We can move the entire lift left or right, or to compensate for any variance in the way the brackets are welded, we have an offset shaft where we can move the lift either left or right, as well as compensate for any variance in height from one kickback to another by using this offset shaft feature. This allows us to align the belt on the track rail assembly. Once we have it centered, we tighten the split shaft and tighten the clamp studs. To check the ball lift height adjustment, we'll put a ball into the exit on the lift arm and look at the space between the lift belt and the ball itself. This space can be changed by using the two rubber bumpers at the upper lift shaft. The two rubber bumpers at the upper lift shaft are used to control the height of the lift, thus controlling the clearance between the lift and the ball. We're looking for about a 1/4 inch clearance. Raising the rubber bumpers increases the clearance, lowering the bumpers decreases the clearance. The drive belt tightener assembly must be repositioned, the clamp studs installed, and then all of the belt tightener springs reinstalled. To check the lift belt alignment on the track rail assembly, we can put a ball into the exit and turn the belt by hand to elevate the ball. Watch to check the clearance between the belt and the spring. If there's insufficient clearance, we would compress the spring, making it smaller, giving us more belt tension, increasing the clearance. We'd also check to make sure that the belt remains flat against the ball. This would tell us that the alignment of the lift is correct. Should the belt be twisting as the ball is elevated, this would also tell us the belt alignment is incorrect, and we would need to reposition the upper or possibly upper and lower links in order to correct the lift alignment. We've taken many of the ball lift components from the machine just to make them easier to view. These are some of the items that we'll be inspecting with our preventative maintenance program. And the first that we are looking at is the ball wipe cloth. There's one of these with each ball lift. It's there simply to wipe the ball every time it goes back to the bowler in order to clean the ball and prevent as much dirt as possible from going back to the bowler. So one of the items that we would reverse regularly and wash on a regular basis. Next, we see the bottom bracket for the track rail assembly. These get damaged, they get bent, need to be straightened or replaced. You'll notice that the elongations there allow us to move this left or right in order to get the track rail assembly centered between the pair of machines. We also see the lower and upper track covers. We can rotate these to bring a new surface to bear against the ball, since only a very small portion is touching at any given time. One of the new products is shown there also. It's the urethane ball door ring, replacing the steel ones that we've used in the past. These virtually eliminate the possibility of any ball damage. The ball lift belt itself, the new style that has the cord in the top, gives a superior ability to work well even under oily conditions. We can use these products on kicker lift as well as on positive ball lift. Many of the components used in the lift are the same, whether it is a kicker or PBL, as with the upper and lower yokes and the ball wheel itself that we see. These are going to be the same regardless of the style lift. We also would inspect closely the link assemblies, both the upper and lower, once again identical components on kickers or PBLs. We see one of the lower drive pulleys. This is the assembly. It does have the one-way clutch pressed into position. This gives our machines the ability to operate independently without having to have both machines on to run the lift. The shafts that we see there, we have two different styles. The one is the D-bore shaft that requires the special bearing with the flat side in the internal race. It looks like the letter D. These do force the inner race of the bearing to turn with the shaft. And also we see the original style shaft there with the three flat sides with the regular 6699 bearing. That does require that these bearings be torqued to the proper specifications in order to ensure that the inner races do turn with the shaft as they should. As we move on, we see we have the paddle assemblies. These are different for kicker and PBL, so we see a difference in the way they are mounted. These again are the urethane paddles that we are using. We find some parts here only used in the kicker lift. We see the regular gray kicker roller, as well as above it the kicker assembly, the shaft and bearings along with the housing. And we're looking at the idler bracket. These are different right or left side. These are the ones that are used to keep the tension on the kicker drive belts. Also looking at the starter pad and the lower track rail bracket that's used only with the kicker lifts. Starter pad's very important for the proper operation of the kicker lift. And lastly, we're looking at the new spring-loaded drive assembly. We're using this to drive the rudder arm in the kicker lifts as opposed to the hydraulic links that we've used in the past. This completes our overview of ball lifts. We've taken a look at both the kicker lift and PBL. For more detailed information on both of these, you are invited to attend our training program in Richmond, Virginia.